a crasher on embedded limits, right? Suppose I had something like this, limit. I'll wipe this off and create room on the board and then come back to this problem at an apt moment, right? So, x tends to 0. Limit e power x minus 1 minus x by x squared as x tends to 0. Oh, look, it would have been e power something minus 1 by something. If this is square, then we should have a square there so that there is matching, right? If there is a x square in the denominator, then e power something minus 1, we should get a square in the numerator also. That's the first thing that you would be tempted to do in your attempt to reduce it to a known format. What do you say? This is limit. What I do is, I write this as e power x by 2 minus 1 whole square plus 2 e power x by 2. 1 I have added, so 1 I subtract minus x divided by x squared. See if you feel okay with what I have done here. This squared would give me e power x, the middle term minus 2 e power x by 2, I balance it with the 2 e power x by 2. The 1 that I have added, I subtract 1 minus 1 minus 1 minus 2 and then minus x. All of this so that, you know, the numerator, this could get commensurate with this. That was the objective. Let me refer to this limit as L. This then is like a limit. I divide this by this. E power x by 2 minus 1 by x by 2 whole squared into 1 by 4. Realize what I did here? This x I wrote as x by 2 whole squared, and this 4 balances this as x tends to 0, right? Then this twice I take 2 common from this, right? And I end up getting e power x by 2 minus 1 minus x by 2. Hey, the numerator has all these x by 2's, so by x squared I write as x by 2 whole squared. You know what I've done here? So far so good? Anshul. This I took 2 common from this, and this x I wrote as x by 2 whole squared, so that this x by 2 and this x by 2 could match. Right? Now, what is this limit? E power something minus 1 minus something by something squared. What was the original limit? E power something minus 1 minus something by something squared. So if this was L, then e power something minus 1 minus something by something squared will also be L. Yes or no? Yes or no? So then L within a L. L equal to, this would be 1 by 4 plus, this would be half of L, this would be half of L, yes or no? Yes, please ask. You look skeptical about whatever I did, suspicious and unsure. Huh? No, trust me, I will not reprimand you for invoking your thoughts. You understood now? Okay. Yes, please ask. No, that's all right.
So why it will be L only? This thing, why your x doesn't match?
Okay. If this is L, what is this limit? E power x minus 1 minus x by x squared as x tends to 0. Right? This is the same as saying that this is like limit e power London minus 1 minus London by London squared as London tends to 0. This is the same as e power Patna minus 1 minus Patna by Patna squared, as Patna tends to 0. Patna is anyway 0. Right? Right? Which is the same as limit e power something minus 1 minus something by something, as that something tends to 0, no matter what this something is. As long as this something is the same as this something, then as that something tends to 0 will always be the same. Yes or no? Yes or no? So this is like e power something minus 1 minus something by something squared. So this is going to be L. So this will become L by 2. So L equal to 1/4 plus L by 2. So this gives me L by 2 equal to 1 by 4 or L equal to half. Yes or no? From now on, for the sake of this class, this is half. Right? Let me tell you another way of doing this. How about it? Can I wipe this off? Have you finished copying? Now, if you had an x here, or a y here, or a t here, or a L here, or a p here, or a minus x here, you're going to get the same limit, isn't it? If you replace x by minus x throughout, you're going to get the same limit, isn't it? Say limit sin x by x as x tends to 0. That's one. Replace x by minus x. Limit sin minus x by minus x as minus x tends to 0, which is the same as x tends to 0. That's also going to be 1. Replacing x by minus x is not going to hurt, right? So let me replace x by minus x. So while minus x tends to 0, x will still tend to 0, right? So let me write this as limit x tends to 0, replacing x by minus x, e power minus x minus 1 plus x by minus x whole squared, which is the same as x squared, right? Clear? Now, if a equals b, then each will be half of a plus b. Yes or no? If a equals b, then each will be a plus b by 2. If a equals b, then each will be half their sum. Each will be half their sum, right? So half of limit at these two, x and x will get cancelled. E power x minus plus e power minus x minus 2 by x squared as x tends to 0. What about this? Right? Clear? This is 1 by e power x. Replacing e power x by 1 by e power 2x minus 2 e power x plus 1 by x squared e power x as x tends to 0. I hope you realize what I did here. So you could say I multiplied numerator denominator with e power x. So e power 2x plus 1 minus 2 e power x multiplying numerator denominator with e power x. Clear? Which is like half of limit e power x minus 1 by x whole squared 1 by e power x as x tends to 0. This is 1. This would be 1. This would be half. Yes or no? Got me? Is that okay? PS. The other thing which I was avoiding to tell you, because I want you to I want to create tough moments for you right now. I don't want you to use all that. But, you know, if you choose to use series expansion, e power x is 1 plus x square by 2 factorial plus etc. Then e power x minus 1 minus x is like x square by 2 factorial plus x cube by 3 factorial and so on and so forth. Divide by x, e power x minus 1 minus x by x, which is like x by 2 factorial plus x square by 3 factorial and so on and so forth. As x tends to 0, this tends, so this is dividing by x, so 1 plus x by 3 factorial on dividing by, as x tends to 0, this whole thing tends to half. So limit of this as x tends to 0 is half. That's series expansion. Yet another thing which I don't want you to use right now, but after you've actually learned the whole idea of limits, then I'll give you the flexibility to use that as well as series expansion. But in our initial digressions on limits, I would not make it permissible to use either series expansion or the next thing that I'm going to tell you. The next thing that I'm going to tell you is a very popular result in limits. If you allow me to wipe this off, can I wipe this off? Right? See, limit fx by gx as x tends to a, if fx tends to 0 and gx tend to 0, either both tend to 0 or both tend to infinity. If both tend to 0 and both tend to infinity, that means it's of the form 0 by 0 or infinity by infinity, then this limit can be written as limit f dash x by g dash x as x tends to a. This is called L'Hopital's rule. This is called L'Hopital's rule. Not L hospital. Don't call it L hospital. You will feel sick. Okay? This is L'Hopital's rule. If there is a limit of the form 0 by 0 or infinity by infinity, you could differentiate numerator and denominator. Right? And again, if this is also 0 by 0, then again you can differentiate. Keep differentiating till such time either it comes to a known form or you get a finite value. Eventually it's not 0 by 0 anymore, right? So coming down to this limit, e power x minus 1 minus x by x squared as x tends to 0. Don't bother about it. The proof is beyond the scope. A proof is certainly not within the scope of things that you know. So, but the application is within the scope. So, let's not bother about the proof of L'Hopital. See, this is of the form 0 by 0. As x tends to 0, this tends to 0. 0 by 0 form, right? So, you could differentiate numerator and denominator. E power x minus 1 by 2x as x tends to 0. But e power x, now you don't differentiate. You have a known form here. E power x minus 1 by x. Don't become a slave of L'Hopital. Okay? E power x minus 1 by x as x tends to 0 is 1. So this becomes half. Right? Let me give you another one. Can I wipe this off? Are you mentally positioned to accept this? Now let me illustrate a little more. Say, if I had limit sin x minus x by x cubed as x tends to 0, hello? No, we will not do that. See, expansion or using L'Hopital is a minute's job. I mean, if you said Sin x is x minus x cube by 3 factorial plus x power 5 by 5 factorial and so on and so forth. Then sin x minus x by x is going to be x square by 3 factor by x cubed is going to be minus 1 by 3 factorial plus x squared by 5 factorial. All of the terms will contain x. As x tends to 0, this tends to minus 1 by 6. This limit would be minus 1 by 6 using series expansion. It's also of the form 0 by 0. So if you differentiate numerator denominator, x tends to 0, cos x minus 1 by 3x squared as x tends to 0. Again it's of the form 0 by 0. So this becomes minus sin x by 6x as x tends to 0. Sin x by x is going to be 1. So this is going to be minus 1 by 6. But I will not allow usage of all this right now. Right? It's as if when a kid is in class 1, you don't give him a calculator. But when he learns how to add, subtract, multiply, divide, etc., and then he uses the calculator, it's fine because he knows that in absence of a calculator, he will still be able to do that if required. Right? So this is like the calculator, which I am not allowing right now. Okay? So what we'll do is we will obtain this using embedded limits. The thing is, if there is a cubed here, you would need a sine cube there. Sin x is 3 sin x by 3 minus 4 sin cubed x by 3. Yes or no? It would be a good idea to bring in a sine cubed in the numerator so that down the line it could become commensurate with the denominator. Right? Let me refer to this as L. To bring a cubed sin x, I write as 3 sin x by 3 minus 4 sin cubed x by 3 minus x by x cubed as x tends to 0. This, of course, I would want to club with this, right? So this I write as limit minus 4 sin x by 3 by x by 3 whole cubed 27, right, to balance that, and then these two terms plus 3, this and this, I take 3 common, right, 3 sin x by 3 minus x by 3 by x cubed. This x cubed I can write as x by 3 whole cubed and then into 27 as x tends to 0. Yes or no? Right? This will become minus 4 by 27. Now, what is this? Sin something minus something by something cubed. As something tends to 0, that's going to be 1. That's going to be L, not 1. That's going to be L. This is sin something minus something by something cubed. Sin something minus something by something cubed. As something tends to 0, that's going to be L. So this would be 1 by 9th of L, 1 by 9th of L, right? So which means L turns out to be minus 4 by 27 plus 1/9 of L, right? That is like 8L by 9 is minus 4 by 27, or L then turns out to be minus 1 by 6, the required limit, right? How I got this? This divided by this, x cube tha, but I wrote it as x by 3 whole cube, and this minus this divided by this. I took 3 common from these two terms. Sin x by 3 minus x by 3, hello, by x cubed. See, these two clubbed together as this term, and from these two I took 3 common. So sin something minus something by something cubed. We had a x cube, but we wrote a x by 3 whole cube, right? right? Let me illustrate a little more. Got me? Down the line, once you get that mental comfort obtaining limits from first principles prima facie, then we'll allow you to use series expansion. I'll allow you to use L'Hopital's rule, etc. In an exam, of course, use series expansion, L'Hopital's left, right, and center wherever applicable. Okay, but as beginners, you know, we will avoid using L'Hopital and series expansion. That will always work. Okay. Say limit x ln x, x tends to 0 from the greater than 0 side. X tends to 0 from the greater than 0 side. X tends to 0 from the less than 0 side will not exist for this limit. Because when x is slightly less than 0, ln x is undefined. Right? Let me refer to this as L. Let me refer to this as L. Right? Now this, whether x or 2x, will it make a difference? ln 2x as x tends to 0. Replacing x by 2x, the limit will not change. Or replacing x by 3x, the limit will not change. Or replacing x by 2, the limit will remain the same. As long as I have done that uniformly throughout. Right? This is twice limit x. ln 2x is ln 2 plus ln x as x tends to 0 from the greater than 0 side. 2 taken common, x into ln 2 plus ln x. Right? Which is like twice limit x ln 2 as x tends to 0. Assuming the limit exists, limit of the product would be product of the limit. I'm sorry, limit of the sum will be sum of the limits if the limit exists. Yes or no? All of this is L? This will be 0. X ln 2 as x tends to 0 is going to be 0. So L will be twice. And this will be L. Limit x ln x as x tends to 0. From the greater than 0 side is L. L equals to L. So L must be 0. L equals to L or L must be 0. L equals x ln 2. That will be 0. X ln x, x tends to 0 from the greater than 0 side will be L. So L equals 2 into 0 plus L, 2L. 2L is 0, so L must be 0. Limit x ln x as x tends to 0 from the greater than 0 side, therefore is 0. This is a very commonly used limit. Standard limit for the sake of our class, right? Now, this you could also write as limit minus ln 1 by x by 1 by x as 1 by x tends to plus infinity. Can I do this? As x tends to 0, 1 by x will tend to plus infinity. And this minus will go to the power and will make it ln x, isn't it? This minus will go to the power and make it x anyways. And this x I have brought to the denominator this way as 1 by x. So this is like limit. So this, all of this is 0, right? All of this is 0. So we have limit ln y, 1 by x is y, by y as y tends to infinity is 0. 1 by x is taken as y. Limit ln y by y as y tends to infinity is going to be 0. Remember in my last class I told you limit ln x by x as x tends to infinity is 0. And I told you that X will increase faster than ln x, y will increase faster than ln y, and ln y by y will tend to 0 as y tends to infinity. Right? If someone said limit x to power x as x tends to 0 from the greater than 0 side, limit x ln x tends to 0 from the greater than 0 side. This is like limit this x I can write as e power ln x. But x ln x as x tends to 0 from the greater than 0 side is 0. So this will become e power 0. That makes it 1. That makes it 1. Limit x power x, x tends to 0 from the greater than 0 side is 1. Sounds all right? Another thing that you can try independently is the following. Limit tan x minus x by x cubed as x tends to 0, etc. You know, things of this sort you can try independently using embedded limits. Not using series expansion, not using L'Hopital's rule. Yes, right, tan x as 3 tan x by 3 minus tan cube by 1 minus 3 tan squared. 3 tan a minus tan cubed a by 1 minus 3 tan squared a, tan cubed, etc. Perform that manipulation and you'll be able to get through. Right? In an exam, you can be rampant with series and with L'Hopital, etc. No one would ever find out how you've obtained the limit. Okay?